Alright, so now we are on Chapter 12, Video Assignment 2. As explained in this problem, the rate of bacterial hydrolysis in fish muscle is twice as great at 2.2 degrees Celsius than it is at negative 1.1 degrees Celsius. So because of that, that detail, that's twice as much, we are going to use the Arrhenius equation, which is ln of K2 over K1. In this case, we already have the ratio of 2. We could do that because it is unitless, and we just need the ratio. We don't need the exact values of K2 and K1. And then equals the negative activation energy, joules per mole, over the R constant, which is 8.3114, and that's going to be in joules, not kilojoules, so we're good there. Equals negative 275.1 over 275.2 K minus, so that's going to be T2 minus T1. And so solving with the calculator, ln2 equals 0.69315 equals negative activation energy over 8.3114, and then solving for these, you find that it's equal to negative 4.41 times 10 to the negative 5, and then you'll divide both sides by this value, negative 4.41 times 10 to the negative 5, and then that is going to equal on this left side, that's going to equal negative 15.717.687 equals negative activation energy over the R constant, multiplying both sides by 8.3114 and by negative 8.3114 to get rid of that negative right there. You get an activation energy of 130.635.98 joules per mole. So the last part of this problem explains that with this increase in temperature from negative 1.1 Celsius to 2.2 Celsius, the rate of bacterial hydrolysis is twice as much. And so what you want to do, and how this relates to storing fish for food, is that obviously so the fish muscle doesn't decompose, you want to store it at a lower temperature because it's twice as much with just that change in temperature of about 3.3 degrees Celsius. And so this activation energy tells us 130.635.98 joules per mole, which is the energy required to start this bacterial hydrolysis in fish muscle. So basically, knowing this activation energy, you should be able to calculate how changing the temperature at which you store fish from one temperature to another hypothetical temperature, you should be able to calculate, using this activation energy, the rate at which bacterial hydrolysis in fish muscle will happen. If you were that concerned about how you stored your fish and changing 3.3 degrees Celsius, how that would change it. So that kind of explains that.